Here's number 1 from 4.4. It says find two numbers whose difference is 150 and whose product is a minimum. So let's just go back here. So right here. Okay. Oops. So number 1, find two numbers whose difference is 150. So that means when you subtract them, the difference is going to be 150, and whose product is a minimum. So there's two major pieces of information there, right? The two numbers are such that when you subtract the large one minus the small one, you're going to get 150. So let's just start with that. Let's say x is the large number, okay, of the two, and y is the smaller number. And when you subtract them, you get an answer of 150. Okay, got that? Good? Alright, and what we're trying to do is we're trying to minimize the product. Product means multiplication. So the product is x times y. Now remember, we have to have p as a function of x, only one variable, right? So we can't have two different variables. So let's see if we can make y into something else. So we take this one up here and we say, alright, what if I did this? I'm going to subtract x from both sides, and then I'm going to divide by -1, and I'm going to get this. Okay? So this becomes a negative, that becomes a positive. So y actually equals x minus 150. So let's put that into our product. X times y is x minus 150. That's key, because that makes this product a function of only one variable. See, I got rid of y. So there's always two pieces of information. This is what you want to maximize here, and this is just the other piece of information that will allow you to isolate one of the variables for substitution. Very important. There's always two equations you can make. One of them is the one you want to optimize. Okay? Any questions about this stage so far? So now we want to take the derivative of this function. Before that, you might want to save yourself some hassle and do this. I would. Because then you don't have to do product rule. You can go, let's multiply these in real quick, and you get x squared minus 150x. Do you see that? That's going to be easier to take the derivative of. So let's take the derivative of this expanded form. And that's going to be 2x minus 150. That's the derivative. So once you've got your function to be maximized, take the derivative and let that derivative now equal 0 to find the critical numbers. So there's 75 is your critical number. And that's the number that you are interested in. Okay? That's the number you're interested in. So if x is 75, then what's y going to be? Well, plug x 75 into x, and you've got y equals 75 minus 150. Y equals negative 75. So the two numbers are 75 and negative 75. If you want to check this, okay, if you take the large one and you minus the small one, you should get 150, and of course you do. When you subtract the negative, that's the same as adding. So it checks out there, and this is going to be quite a large product because you've got two fairly large numbers. Sorry, it's going to be a large number, but it's going to be largely negative, so we're trying to, I think I wrote max there. Oh, and it should be min, sorry. So I wrote max up here earlier. It should be minimized. We're trying to minimize this product, minimize. And we're going to have a very large negative number. So 75 times negative 75 is going to be negative 5,625. And that's going to be your very, very small because it's a negative product. So yeah, so my bad here. We were trying to optimize here this product, and we're trying to minimize it. So you can see that's a very, very small number because it's negative. Okay. So the question says, find two numbers. So your answer has to be, the numbers are 75 and negative 75. That's your answer. That's 4.4, number 1.